Today we are going to start with the advanced MapReduce concept, and these are the topics for today. Right. So today what we are going to do is we are going to build on whatever the concept we learned in the previous class, and along with that we will learn some of the common thing which as a developer you have to be aware in terms of the MapReduce developer. Right. So few of the common scenario like uh, in the previous class also people have the question like how to redirect your output, like the reducer, how the reducer works, kind of things, right? And then like one of the critical thing when you will go for this data processing by using the Hadoop framework, it will be like how to do the join, right? So we are going to see about like in MapReduce, suppose if you have to do the join, if you compare to SQL, you just write a join statement and you are able to do that. But when it comes to the MapReduce, it is a more involved kind of the join where you as a programmer need to take care of the all the aspects of the join, right? How you read the data, how you face the column, and all those things. So let's get started, guys. So how the MapReduce framework works, guys, is you have the input data, and whenever you want to run a MapReduce code on that, first thing what you will do is you will bring that data inside the HDFS. And that's the two main components we have in the whole Hadoop learning or whatever we are discussing about the Hadoop framework. One is Hadoop file system, and then the MapReduce, which you run on top of the HDFS. So now to run the MapReduce, what you have to do is you have to first bring the data inside the Hadoop. So whenever you bring any data inside the Hadoop, the data get distributed across multiple nodes, and once the data is distributed across the multiple nodes, what happens is like the data get divided on the level of the block. So you have a block size configuration. If you guys remember the configuration files we see, right, where you in the hdfs-site.xml you can specify what is the block size, so generally 64 MB or 128 MB, and based on that your data will get divided across multiple machines, and each of the block will be replicated across multiple copies in the cluster based on the replication factor which we set inside the cluster. So by default the replication factor is the 3, and based on that the data will get replicated across multiple machines. So this reliability or this duplication of the data which you see in the cluster, it is on the block level, not on the file level. So every time you will have each block which will be present on the 3 different machines. So if one machine goes down, you can still access it from the other machine, and you can continue with the processing. So that's way the data comes inside the node, and it gets distributed across the node. And once you have your data distributed across the node, what you do is you write your MapReduce code. Hope you guys remember this particular thing which we wrote in the previous class, where you take an input path and you take a output path where you want to store the data. You write the logic how to read the data. So basically you get the input data, you split it based on this, based on the like how you want to tokenize the whole input data set. So like for each new line you take as one particular record key and value pair, and for each of the line you divide it each word by separated by space, so you divide it in a different word, and for each word you want to count it like how many times it has occurred. So this is the like if the input is this is my, so you want to count like how many times each word has occurred in a given input data set. So that particular things goes like for the MapReduce program to process that. So it goes the input data set goes to the mapper, and mapper first what it does is in the stage 1 it just does the mapping where it says that okay, each word has whenever it see a particular word it will just mark it as like the word and the 1. So that's the key value pair it will output, and that you will connect in the output collector. And once you have all this data coming out from the mapper, it's good that it has processed all the data, but that's not the final objective which we want to access. So what we want to do is like we want to get the final count where we want to find it out like how many times each word has occurred inside a given input data set. So to do that, what we have to do is we have to bring all the data set for that particular word together so that we can do the count. Like suppose if this has occurred 3 times, you want to make sure that all this like this one, and this one 3 times whenever it get processed inside the map, it has to come to a reducer so that we can aggregate it or we can count it and we can get the final sum. So for that purpose, what you have to do is you have to basically move your data from the mapper to the reducer so that it can do the aggregation. And while moving the data from mapper to the reducer, you have to make sure that all of the input data set for a given key should go to one particular reducer. And the reason why you have to basically go for this particular approach is because whenever you are using the reducer, it's basically going to do the aggregate or the sum of whatever the input data set you have. Now to get the final picture, you have to have all the key value pair for a given key available to the reducer so that it can do the final aggregation. Now, in a distributed framework, how you basically enable this kind of the processing is you use the concept of something called the partitioner. So partitioner is something by using which you will basically put a framework which will determine that whenever a output coming from the mapper, it will have a different function. It will have a particular logic, and based on that logic, every time that mapper output will go to a particular reducer. So in general, or by default implementation is the hash partitioner. So whatever the key you are using for that key, there will be a hash value calculated, and based on that particular hash value, you will move that data set, move that particular key and value pair to one particular reducer. So you can think of like suppose if you have the 4 reducers, so normal like think of like hash partitioner, like suppose it is implemented as a modulo function. So you will divide whatever the key value you are getting, you will take a modulo by 4, and based on that you will get a number between 0 to 3, and whenever you get a number you will assign that particular key value pair to that particular reducer. So that's the process. It is called the shuffling phase where you move the data from the mapper to the reducer, and this is the only phase where in the whole framework where you are going to basically move the data or move the data across the network. So that's the phase called shuffling phase where you are going to move the data. Okay, and once all this the movement of the data happens between the mapper and the reducer, then the reducer comes in the execution, because it needs all the data set from the mapper to start execution. So once the data set is available to the reducer, it starts processing that input data set, and once you get the data processed by the reducer, the output of each of these reducer, it will go into a separate file. And the reason why, suppose if you are using 5 reducers, so you will get 5 different output file, and in case if they have the data, right, so 5 different output file you will get inside the output directory, where each reducer will write in its own file. And the reason we have this kind of the architecture where everything runs independently is because you don't want to have a communication overhead between the two processes, because that becomes a costly in terms of the time it takes and also to maintain the state. So one thing we have to understand in the MapReduce program is like you put your algorithm or you put your logic in such a way that it can run independently. So if you have to share the state or like between one process, one phase, like one mapper has to communicate to other mapper. So those kind of the framework, those kind of the algorithms will not be suitable for the MapReduce, because here mapper works independently, the reducer works independently, right? Only communication happen between the mapper and the reducer. So apart from that phase, whole processing has to happen in parallel. So if you have any kind of algorithm which will not be able to fit in this particular framework, in that case you will not be you will not be able to use this MapReduce framework to process those kind of algorithms. And that's why we have some of the limitation where some algorithms cannot be expressed as a MapReduce program, like if you are doing some graph processing or something. So for those kind of algorithms, we were not able to put into a this whole MapReduce kind of the architecture. Okay. Let me see a couple of questions here. Okay. Okay, so Hitesh says, does the partitioner come in picture in the pseudo distributed? I think you mentioned partitioner plays the role of in the distributed mode. No, so yeah, if you have multiple reducer, Hitesh, there it comes in, and in this pseudo distributed mode also you can simulate these kind of things. So it does come in picture. Menu has doesn't all output from the reducer must get aggregated for the final result. I see there is a node 1 and node 2, so a user needs to write another reducer for outputting the final result. So how it happens? This particular thing, what you are seeing here, it's just to see you that one particular file, another. Okay. After that, what happens? Each of these file again, it will go through this Hadoop write process where it will you will provide a location, the directory location, and there the file you will create. So all these three files will be accessed in that particular directory. And these files, suppose if it is like a 100 GB file, it is coming from the reducer. So again, this file will get distributed across different blocks inside the Hadoop. So all those things, concept still remain same. How the files are going to be stored inside the cluster. So those things still remain same, in terms of how the storage will be there. Here, just to denote that each of the reducer is working independently and on each of the node and giving you the output. Okay, but all of them are going to write on the same namespace, the same output directory where you provide. Only thing is, there each of the node they will write, each of the reducer they will write on a separate file. Not each of the node, each of the reducer will write on the separate output file. And once we'll see the example of the partitioner, these things will be clear to you, where you will be able to see that, okay, this data get distributed based on the which reducer it is processing. Okay, so we'll see about that. Okay, so is that answer your question, Meenu? Okay, and Ashish, so can I say that partitioner is responsible for directing the intermediate data of the same key to the same reducer? Exactly, Ashish, that's the role of the partitioner. So for each key, it will determine how to move the data from that mapper output to which reducer. So that will be determined by the partitioner. And if you are using, the one partitioner, so in that case, what will happen? All of those keys will go to one particular partitioner. Yeah. So this only one copy of the output will be saved after the reducer write, not the three by default. No, it will be three, Satish, because whenever you write anything inside the Hadoop, so all these reducer output will be also stored as a SDFS file. So whenever you will store anything inside the Hadoop, it will go basically the same writing process where it will involve the name node, get the block location, and then it will write that. So it will go through like three copies. Okay, Minu, we'll go through the examples and things will be clear. Okay. Okay. And if you want to reduce this traffic, right, we saw another concept while moving the data from the mapper to reducer. So instead of transferring each key value pair as it is, what you can do, you can basically consolidate all those things at the mapper output level. So you can have one key and the associated value, and that particular value you can transfer that. So that you can do by using the concept called combiner. Okay. So I hope this gives you a quick overview, like what all we discussed in the previous class about how the MapReduce flow works, right? Any question you have before I proceed with the showing you how to use the partitioner and combiner? Okay, I do see a couple of questions coming here. Okay, let me mean. Okay, just a follow-up question. So from distributing the base data, how many ever nodes we have? We will have that much reducer. Now, I'm just trying to read your question, Minu, again. Okay, based on the data, how many ever nodes we have? We will have that much reducer. Okay, so your question is it like suppose if you have 15 nodes inside the cluster, the output node, or the processing node. So you mean the 15 reducer is going to run? Is that your question, Minu? Okay, no. So it's not determined like that way. So if you have the 15 nodes, it may happen that all of your data will get stored on all those 15 nodes. But the number of the reducer which you want to determine, that will be something you can control from the program. So you can determine how many number of the reducer you want to run. So you may run 15 reducer, you may run 5 reducer, or the 10 reducer. So how it will be determined is, generally in a Hadoop kind of the cluster where you will have multiple, the projects or the programs that will be running inside the cluster. So each of the program will get something called the queue. So the number of the reducer and number of the map slots which we have in the cluster, that will be determined based on the how many cores you have inside the cluster. So based on that, you will determine how many number of the slots you will reserve for the mapper and how many slots you will have for the reducer. So suppose if you have 40 reducer slots available in the cluster, if it's a small cluster, so out of that, suppose for your particular key you have 15 reducer assigned. Out of that, suppose 3 jobs are running, so each of them can run maximum like 5 reducer or something. So that particular setting you will do as part of the program. Whenever you are running the program, you can specify how many reducer you want to run. So you can run one reducer. If you don't specify anything, by default everything will go to one particular reducer. So you will run one single instance of the reducer. Or what you can do, you can specify like 4 or 5 reducer, and based on that your data will get divided into those 4 and 5 reducer, and then you will get the final output. So that's the way the number of the reducer is going to be determined. So you can specify that when submitting the command on the command line, as well as inside the Hadoop code you can. Okay, you got it. Okay, cool. Okay. Okay, I think we have not seen the join, but any has a question here, guys. Okay, so before I take any question, I would like to take any other question, guys, in terms of this whole framework. Are you guys clear how the map, reduce, partitioner, combiner, it works? And although we are going to see again how to create the jar file and all those things we are going to see, but the concept wise is this whole diagram is clear. It should be clear in your mind, right? How the input will go to the mapper will process that, then you will have the key value pair. If you use the combiner, it will consolidate all those output from the mapper, and then you will move that to the reducer. And once it goes to the reducer, it will do the processing, and then you will get the final output set, right, by using the partitional logic. Is this clear? Okay, so I get me clear, Devinder, Hitesh. Okay, and how about other people? Just 3 people. Let's tell me yes, right? Because I need this thing. If you have any confusion doubt, just let me know. I would like to take that one. And Subhajit says, can you please explain the modular calculation? Okay, sure, Subhajit. Okay. Okay, let me show you. So suppose modular calculation, it works simple. Subhajit, so suppose if you have 4 reducer, so now you think of like each of the key, right? So you have maybe in the one word 1, 2, okay, 3. So now what will happen for each of the key, what you will calculate is the modulo function. So since the number of the reducer is 4, so you will calculate modulo by 4. And what it will output you is, right, any number. If you can calculate the modulo, it will get, you will get any number between 0 to 3, some number it will come, right? So you will get maybe suppose 2 here, right? So it means the reducer will be generally between 0 to 3, that it will be numbered by 0 to 3. So when you specify this, you get a number 2, it means it will go to the 0, 1, 2, and 3. So it will go to the third reducer, and it will process that. Okay. Similarly, for this particular key, you may get a value something like the 1 or 2. But 1, if in that case, it will go to the second reducer. Okay. In the word 3, it can happen that it can again have the output as 2, right? Because 2 of the key may have same output. Like if you go 14 divided by modulo, it will, take the example like 2, right? So if you're dividing any particular word, it may have a modulo 2. Another word can also result in the modulo 2, right? So what the reducer says that all that reducer wants is for that particular key, give me all the input data set. That's the reducer. It doesn't restrict that, okay, I will only process one particular key, because it's not possible, because you will have multiple keys which the modulo function will result in the same value. So that's what you will have, like number of mappers, suppose 5,000 you have, then the number of the reducer you will have only 30 and the 40, and all these different keys will get divided into these 30 and the 40 reducer, which you will run inside the cluster. So each of the reducer may get multiple keys to process, but whenever they get any particular key to process, they will get all the input data set for that particular key to process that, right? So that's the overall concept we have, like how the partitioner will make sure that all of the key value pair goes to a particular reducer. Okay. Is this clear, Subhajit? Yeah, You got it? Okay. Okay. Anybody has any other question? Hey, no problem, Subhajit. Okay. Okay, cool. Okay. So now since you guys have no question, right? So here Amy has some question. So let's take some question from Amy. So can you use the MapReduce algorithm to perform a relational join on two large tables sharing a key? Assume that the two tables are formatted in comma separated files in HDFS. So this question is just a guess, guys, because till now I have not told you about the join. I think any question came a bit early. So yeah, just a guess. Do you guys think a join can happen in using the MapReduce code? We'll learn about that, right? How it happens. So maybe it's just a kind of a guess for you. Okay. Okay. So all of you think that yes, a join kind of operation can be performed by using this. Okay. Yeah. Yeah. So there are a couple of ways how to do the join. So there is a map side join, reduce side join, in-memory join. So we are going to talk about that, like how to do these different kind of a join inside the cluster, Hadoop, inside the Hadoop framework. Okay. So here is another question from Annie. Okay. So what type of algorithms are difficult to express in the MapReduce? Okay. So this you should be able to understand about the whole flow, right? So just we discussed, right? So algorithm that require global or shared state, or algorithm that require applying the same mathematical function on the large number of individual binary records. Okay. So only two options. So just pick it up, whichever. Okay, so which kind of the algorithms will be difficult to implement based on the how you see that how the MapReduce works, right? Based on that particular flow, how you think that which is difficult generally to implement that? Yeah, so I get a couple of answers here, and people like wherever that requires global and the shared state, right? Yeah, so those kind of algorithms are really going to be difficult to express that in the, yeah, thanks Patrick, Mang. Yeah, Sachin said second one. No, Sachin, it's the first one. So all the, the program or the algorithm where if you have to share the state, it's going to become difficult for the MapReduce to implement that, because if you see the mapper and the reducer where the core processing happens, those particular functions works independently, so they don't share any kind of the state that okay, I currently my status is like this, I have the count value is 4, and then your count value is 2, so add it and then do some kind of processing. So there is no communication happens between all these processing part, the mapper and the reducer part. So all of them run independently. And due to that, if any that kind of the sharing is needed, so those kind of things, it will not be possible to implement using this particular flow, the MapReduce flow. Okay. So if you guys remember the example which we saw where we had the counting problem in our hand, right? So when we wanted to do the count, there was one way where you can share the state between each process, so that like you can count it, right? Whenever one process finish, it pass the value to the next process, and then it continue with the processing. Right? To give the example, right, in the last class, what we discussed is uh, if you have the word count example, if you want to do that, one is like one mapper completes the reading of one particular input line, and once it finds that okay, each word has like 4 times or 5 times, then it pass that particular thing to the next mapper, and when the next mapper runs, it processes that, right? So that could have been like one kind of the implementation, but in that case you share the state, and suppose if this map goes down, then again you have to dependent on this to come up and then reprocess and all those things. So in our case, that's not the case. Here in the MapReduce framework, everything runs independently and you don't share any state between each other. Yeah. Yeah, it's like a kind of sequence, like one process output go to the another process, that kind of the sequence. So those kind of things we don't have here in the MapReduce framework. Yeah. Okay. Okay. At what stage in the MapReduce task execution a reduce function starts? In general, right? This is something you can configure it, but in generally, like when the reducer will start working on a given data set, which is coming from the mapper. Okay, I see a couple of answers here. So all of you guys can be interactive guys here on the question window, because this is the only way I can interact with you. I can see your answers and I can provide the clarification. So just be interactive. All of you try to attempt the question. Don't worry about right and wrong answer. Right? If it is not correct, it will help me to explain you right out if any other concept which is not clear kind of thing. So please, all of you try to answer that. Bhaskar says, Bhaskar, I see your option 3 as the answer. Anything, any other question you have? Okay. Yeah. So it basically starts after the map task has completed, and the reason is because if you want to do any kind of the aggregation or the summarization of the data, reducer has to basically get all the input data set and process that. So this is something, if you will go to the actual implementation of this one, this is the the theoretical stuff, right? When the reducer has to start, it has to start only after all the output from the mapper is available. But before that, there is a process where the mapper moves the data, where the reducer needs to move the data from mapper so that it can start processing. So that shuffling process, sometimes it starts, that's configurable. You can start it as soon as the mapper output is coming. You can start the shuffling process. So that happens sometime, right, where you will see that it starts, but actually not the reducer is working, but that particular time the shuffling process is what it's happening inside the cluster. But generally, yes, reducer will work only when the mapper output is coming. Yeah. Okay. Okay, so this one is interesting one, if you guys remember the concept. So if you want to reduce the traffic between mapper and the reducer, your class should implement which interface? Partitioner, combiner, writable, comparable. Which particular thing basically reduce the traffic between the mapper and the reducer, where we have the bottleneck in terms of the disk as well as the network kind of things. Okay, and I want answer from all of you, because this will help me to understand that you are clear with all these concepts, these terms, guys. So please, can you all of you try to answer this one? Right, wrong, don't worry about that. Vasquez is confused now. Okay. Oh, no, no problem. Okay, I will explain you. Okay, it will be clear. Don't worry about that. It will be clear. Okay. 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 So the right answer is the combiner. So if you want to basically move the data from mapper to the reducer, the logic how to move the data, how to yeah, thanks Bhaskar, you got it right. Yeah, so if you want to move the data from mapper to reducer, you have to put a logic, and that particular logic, how the data transfer will happen, that will be done by using the concept what we have called the partitioner. Now, what the combiner concept is, since the mapper output, it will come each key in the value pair we are going to get. Right? For each of the word, we are going to mark it as 1, and that's what we are going to output. Now, if you just transfer that whole, each that granular level, if you transfer the data, it will be too much data to be transferred across the network. So what you can do is you can implement a combiner logic, and that logic, what it will do is instead of moving the whole data set across the network, it will just combine all the mapper output, and then it will move that particular data set to the reducer. So that way you will have the less traffic going to the reducer. Yeah, so it basically acts as a mini reducer, and it can basically take some of the work away from the reducer, do it locally on the mapper output, and then pass that output to the reducer, which will get processed. So this is the concept combiner and the partitioner. So combiners can be viewed as a mini reducer in the map phase, where it will take the mapper output but each mapper will have its own combiner, which it will run on top of the mapper output, and then you will get the sum value for that mapper output. And then the partitioner, it basically determines which reducer is responsible for a particular key. So that will say that, okay, this key has to go to reducer number this. So that thing will be determined by the partitioner, while the combiner, what it does is whatever the reducer is going to do the aggregation of the data, same thing, reducer will work on the whole data set. Combiner, only on the mapper output, it will do the similar kind of the function, and then you will be able to get the consolidated output of the mapper. So next what we are going to see is we are going to see an example of the combiner and the partitioner, where we will see that if you have to write your own partitioner. So till now we have been learning about like the default partitioner, and I'm telling you that you have the multiple files where the data will get stored. So now what we will see is that how this partitioner works and how you can implement your own partitioner, and by using that you will be able to basically control how the data distribution we are going to happen inside the cluster, right? So whenever you have the multiple reducer and you need some kind of the way to determine which is the appropriate the reducer where you want to send a particular key value pair, and that's where you write your own partitioner to determine that. And the default, if you don't write it, it's a kind of the hash value for the key, and that will determine which reducer you have. And if you want to implement your own partitioner, what you have to do is you have to basically implement two functions called configure and the get partitioner. So by using these two functions, you will be able to implement your own partitioner. So what the get partitioner will do is it will get a kind of the integer number between the whatever the number of the reducer you have. So suppose the number of reducer is 4, so it will get a number between 0 to 3, and that will determine like which partitioner it has to send particular value. And the configure is basically to configure the partitioner to run on a given key value pair. So let me show you. So in this example, what we are going to see is we are going to see an example like how you can write your own partitioner, and based on that your data will get distributed based on the logic whatever you are going to write for the partitioner. Based on that particular logic, your data will get divided to the different reducers. Right. Yeah. Okay. So here what we are going to do, apart from the flow what we have where we specify what is the mapper class, what is the the reducer class we have. Okay. And one more thing, guys, I'm not sure if we discussed about the combiner in the last class, this example, but if you want to specify for a combiner, all you have to do is like whatever the, in case if you are using the same logic what you are using for the reducer to use in the combiner, what you can do is you can use this const.set combiner class, and whatever the logic you have for written for reduce that class, same you can pass it to the combiner, because if you see right in this case, like yeah. So what we are doing is here is we are writing our own combiner and the partitioner class, and I'm going to explain you like what we are going to do here and how we do that. So this is like whenever you write a MapReduce code, what you have to do is basically you have to write the mapper class, you have to write the reducer class, and you have to write the driver class. So there is the three things which in the MapReduce framework is there. So mapper, you write the mapper logic, reducer, you write the reducer logic, and driver, basically you control whole the execution, like which mapper it has to run, what is the input format, what is the output format, right? What is the input data file path, what is the output data file path. So all those kind of things you control inside the driver class. So driver class is basically nothing like you can relate it with your like something main class which you have in the normal programming, where you basically start the whole execution and then you run the job. Right. So here in this example, what we want to do is we want to write our own partitioner. So what we want to do is like let me take one example here. So we want to write our own partitioner so that we can, define that how our data is going to be divided between the different reducer. And the reason we want is like once you will see that how the division happens, it will give like in the practical scenario you want to basically control it so that you can, like suppose if you want to like segregate your input data set into different output file, how you want to do that is it will be controlled by using the partitional logic. You will be able to move all the data set to the different files so that you can take that particular thing and you can export it or load into a table or whatever you want to do that. Okay, so in our case what we want to do is like suppose if you have a given input line this is my Hadoop world, this is your, okay. So suppose if you have these two the input lines, and if you want to decided the partitioner that all of these keywords like this, it has to go to reducer number 1. It will process only this keyword called this, and like suppose reducer 2, it's going to process maybe Hadoop, right? So this particular has to be processed by the Hadoop, and then you will have the reducer 3, which will be basically having the world as the output. Now, if you want to do it like this particular way, you can write in your own partitioner, and you can control that. And the reason why we go for this kind of things is like suppose if you are processing an input data set where the key is like based on like suppose if you have a kind of a data set like where you have for each company IDs, right? Suppose if you are capturing to the multiple vendors and each vendor has a ID, right, company ID, and you have couple of the transaction coming from them, and all these transaction is like one input data set. Now while you are processing, you want to make sure that whatever the aggregation you are doing for like if this particular vendor you want to determine how many times they met the purchase order, or how many times they were able to supply the things on time, right? Anything if you want to do those kind of things, what you can do is you have to basically bring all those data set together and then the processing that. Now while doing that, what you can do that if you don't write your partitioner, what will happen? This company ID, it will go to the hash function and it will go to some reducer and it will do the processing. Now in that case you will have the mix of the data because that particular reducer can have other key which has the similar hash value and it can the process that as well. Now if you want to very specific, like that you have the 10 vendors and you want when the input, suppose whatever the 100, 200 GB your data you are getting, when it comes to the output you want to basically separate it out all the data set into the different output files so that you can take that file and you can process that. So how you can do, you can write your custom partitioner and you can tell that anything is starting with the company 1, it has to go to the reducer 1. Right, anything starting with like the vendor 2 or a company 2, it has to go to the reducer 2. So you can specify how you will specify. I'm going to show you in the exam, right? So example. So once you specify this kind of the logic, right, how your data partitioning is going to happen, your whole the whole data will get processed with this particular logic, and you will have all these different files. So it will have one file which will contain all the details about all the input data set, output data set for that company 1, which will process by the MapReduce framework. And similarly for the other like vendor 2, it will have another file where you will have all the data set for that particular vendor. Okay. So now let me show you like how you do inside the program, how you basically write this one. So you get this like your mapper and reducer class, you write it, and then you specify that you are going to implement your own partitioner. So you specify like set partitioner class, and you are telling that okay, I'm going to implement something called my partitioner.class, and you are going to write a logic how to basically partition this particular whole input data set, right? So we will see how to do that. Okay, and then you see like what is the output key class. So it is the text which is going to be output, and value class is interactable. So in this case, what we are doing is, whatever the input data set we are giving like this is my Hadoop world, right? So in this case, we want to count each word, but whenever we are counting, we want to make sure the output of each word, it goes to one particular reducer. Like if it is a this, it has to go to the reducer number 0 or 1. If it is, it has to go to the register number 2. So that way we want to control how the reducer, which reducer is going to work on given input data set. Okay. And then you have the input format, the text input format, the data which is coming, and the output format, again text output format, whatever the data is coming, we are going to write into the output folder. And then the input file format, it's again we have the argument 0, that's the input we are going to take, and argument 1, that's where our output is going to be stored. And how to read this data, that is something set here like text input format. So we are going to read the data as the text. So what it means that whatever the input data set we will get, it will start line offset as the key and the rest of the content till the new line as the value. So that way we are basically telling our program how to read that input data set to process that inside this particular program. Okay. Now the logic for the mapper, it's again going to be same what we have in the previous class. So you basically implement the map methods. You have the key long writable as the key, line offset as the key, and the text as the value. And what output you get is basically set of the like the list of the key and the value pair, so that you collect is using output collector where you have the text and the value. And for each of the line, when you get, you convert into the string, and then once you convert into the string, you basically do the tokenizer, that is like the space or the tab or the comma. You can define like how you want to tokenize the word. In our case, we are just using the default one, so by using the space, we are tokenizing each of the word. And once you have that one, what you are doing is for each of the word, you are setting it like this. Like suppose the input line is I am fine, twice it is repeating. So in this case, what will happen? Each of the word, it will get output like this way. So now instead of passing all these value like this particular way, like each like in this case you see I is 1 and I is 1. So instead of passing all these I1 and I1 to the reducer, what you can do is you can write a combiner, and what the combiner will do, it will basically combine these two outputs coming from one mapper, and it will pass like I2, and that will be the value it will go to the reducer. So how you implement that one is, if you have noticed in the driver class, what we have is we have set the combiner class, and that is similar to whatever the function you have written for the reduce. So in this case, what will happen, it will call the same logic to aggregate this value on the mapper output, and that's the output which will get transferred to the reducer. Okay, and then what you have is you have this partitioner logic. So the partitioner logic is the logic which is actually going to determine how your data is going to be transferred from one reducer to another reducer. So what you can do is you can implement this partitioner. So all you have to do is you have to use this get partitioner to get the number, like which will be a number between 0 to the number of the reducer which you have. So in our case, if you see, we have set the number of the reducer to as 3. So I think somebody had the question, right, how to set the number of the reducer. So you can see inside the program itself, you can set how many number of the reducer you want to run. Yeah. Yes, Satish, your question, yeah, you got answer? Okay. When do you people go and change the partition? That's what I'm explaining, Minu, here, like when to change the partition, okay? And Ashwarya, okay, mobile number, every number has 10 digits, how we can process this? Okay, I will come back to your question, Ashwarya, okay? So the partitioner can be used only for custom data streaming using the MapReduce. Yes, it is, yes. You got it, Minu. Yeah. So now what you are doing is by using this set number of the reducer task, you are telling that, okay, I have like 3 reducer which I want to run. So give me a number between 0 to 2, and based on that, I'm going to determine that which reducer I have to output the data. So now what you are doing is like to determine like how you want to do. So one was like that you take the key, you calculate the hash value, you get a number, and based on the number you determine which reducer it has to go. There is another way. Now what you are doing is we are writing our own method how to do that, and that is using the get partitioner. So by using this get partitioner method, what we are doing is we are going to get what is the reducer number where the data has to be flow from the mapper to the reducer. So how you implement this get partitioner is you get the key, whatever the key you have, you are converting here into the lowercase so that you can do the comparison. So you can have the case sensitive in this case. you can have the case insert also, and then that way also data will get processed, right? So in our case, what we are doing is we are converting the key to the lower case, and after that, what we are doing is we are saying that, okay, if my key equals to Hadoop, send it to the return a value called 0. So what means it send it to the reducer number, the first reducer which we have inside the cluster. If the key value is equal to the data, send it to the reducer number 2 which we have inside the cluster, right? So that's why I'm telling you. If it doesn't match all these Hadoop and the data, send everything to the the default reducer, that is reducer 2, and where it will get processed. So number of the reducer we had the 3. So 0 we have put the logic, 1 we have put the logic, and the third we have put the logic. That default everything will come to the reducer 3. So if any word any key which will be equal to Hadoop, it will go here. Anything which is equal to the data, it will go here, and rest of the things, whatever is not processed, all this will go to this input data set. So that's the way you will. So in this way, what you are going to do is you are going to make sure that which particular reducer is going to get which input key, right? So if you see here, this particular example, get partitioner, here we are not using the hash value which we discussed earlier, right? So here the hash value was like, for a given key, like suppose if the key is like 12 and you have the number of the reducer as 10. So if you calculate the modulo by using the default, so what will happen, you will get a number 2, and that is the hash value you are getting as 2, and based on this you will tell that, okay, the reducer, second reducer, it has to go. Now, instead of going for this particular logic or dividing that, we are writing our own logic, and that particular logic is like, okay, if the input key is equal to this particular word, and that is the custom partitioner we have. We are not using that, the hash value to calculate. Here we are writing our own key. So you get a key, you compare it with a value, and based on that, you are returning it a number, and that number is basically nothing but the reducer number where it has to flow that particular output of the mapper to this particular reducer. So that's what you are implementing in the custom partitioner. Yeah, it is. It's a function provided by the MapReduce framework that you have to override. Yes, that's the thing. Yeah. So all those things, like all these things will be is getting provided to you by the Hadoop framework, right? Yeah. Sorry to ask, but can you tell me what is the hash value? Okay. Actually, hash value is nothing but how you calculate for a given key. You calculate a unique value out of that. So one way is the modulo. There are other functions by using that you can come up with a very efficient hash value, and that will very unique, or it will not repeat, those kind of things, right? So there is a lot of, like, when it comes to the data distribution, you use all this hashing algorithm to come up with a value for a given particular key. So in our custom partitioner, we are not using the hash value. That's what I'm saying. So here we are writing our own logic that if the key is equal to this particular word, then move this data to the reducer 2, reducer 0, 1, and 2 kind of things. Okay. And then you have this reducer function where what you are doing, again, you are getting all the value, and till you have the value, you are doing the sum. And once you get the sum, you will basically output that value, and you will get the final count of like how many times each word has occurred inside a given input data set. Okay. So the core of this whole implementation, and where I want you to focus, is like how to implement this partitioner. So that's what you are doing, using this, the get partitioner. You are using this particular method to get the partition number or the reducer number where you have to move the data. So using this get partitioner, you are implementing your own algorithm how to get that particular partition number. And the logic is we are comparing each word. So we want to basically now control based on the each key value. So these key value has to go to this particular reducer. So if you take this example, what we were discussing earlier. So suppose if you want to based on the company ID, so what you will do is, like, suppose if you have the 10 vendors. So for each vendor you will tell that, okay, if the customer ID is equal to this particular thing, maybe the vendor 1, send it to this particular reducer. If customer 2, send it to the reducer 2. So that way you will be able to control how the reducer output is going to be there. So how basically whole MapReduce flow is going to output the data set. And then if anything doesn't match with this particular thing what you have put, it will go to the default reducer, and you will be able to get the output there. Okay. So that way you implement your own partitioner. You are not using here the hash value to just move the data, but instead you have put your own logic how to move the data, and based on that your program is going to work and move the data between the mapper to the reducer by using this particular algorithm. Okay. So now what I will do, guys, is I will show you with an example like how this thing works, and I think that will give you the clear sense how you are able to control using this partitioner to the output, right? So let me bring the virtual machine here. Okay, let it come. So what it says, can a single reducer work on two different keys simultaneously? Okay. So what happens, Subhajit, is like whatever the input data set you provide to a particular reducer, it does a sorting, and based on that sorted data, it starts the processing. Okay. Let me close all this. Okay. Okay. So before I go here, guys, any other question with this particular partitional logic? Are you guys able to get a sense, right? I'm going to show you how to work that. So all the logic what we have put is like for a given input key. Key is our word, right? Key value pair. So given input key, whenever it has a particular value, as Hadoop, it will go to one reducer. If it is a value data, it will go to another reducer. So that's the way we are going to put a logic here, and we are going to control which reducer is going to get what particular input data set. Okay, so let me come back here. Okay, so let me create a project here called Java project, and then give me like name it advanced MapReduce morning. Oh, it's already there. Okay. Okay. So now let me take this code first and then explain you, right? Okay. Okay. So in this case, what we are doing is whatever the input data set we are providing, based on the input data set, if the key is equal to one particular word, we want to control where the reducer has to go, right? So now, okay, so first let's do a thing. So first let's include the jar file. So all these, the definitions is available. And Hitesh will you share these codes so that we can practice. Sure, Hitesh, all these codes, whatever I'm going to discuss in the class, it will be shared in the LMS. And you should be able to access that, okay? And in case if you're not, just check with the support team and make sure you get a copy of this code, okay? So yes, it's all, everything will be available to you. Okay. So how you implement where the jar file is there, or how you include that? You do you go to the build path, configure build path, and you have to basically include some of the core Hadoop libraries what we have. So you take it everything here user lib Hadoop, right? So there's the user lib Hadoop. You go and then you basically get all the jar files whatever we have. You do okay. Okay, so everything is there. Okay. So we'll rename it with partitioner. So here the one thing is the whatever the class you are going to write and the file which you are going to say both should have the same name. So in case if there you can just rename it this way or other way, and you will be able to resolve that. Okay. So now let's do something here. So how many reducer we have? Number of the reducer is set by this particular thing. Set number of the reducer task 3. So let's see that we want to number of the reducer we want to as a 5. So now what we can do is we can write our own way how the data will get transferred there. So as you can see here, we have all these, the way the data has the data is going to be, let me put it here. Right. So now we have the 5 partitioners, so you can have 5 different way how the data is going to be transferred. So let me take some of the people who were confused here with the partitioner thing, or if you have the questions. Okay. So let me take first Hitesh. Okay. Okay. So what we are telling here is that if any key or any word which will have value Hitesh, send it to the the reducer number, third reducer. So that will be like 0, 1, 2, right? So now suppose if anything is related to let me do that. And so this is, if you do not mention the condition for some of the reducer, they will not be utilized. They will go to the default reducer stage. Okay. So like suppose third one is like Edureka, right? Okay. But we are telling go to the reducer number 4. 0, 1, hold on. 2, 1 sequence, 3. Okay. And rest of the things go to the reducer number 4. Okay. So what we are doing here, a number of the reducer what we have is 5, right? So all the 5 reducer we are writing a logic how the data will get distributed. So we are telling that if the data is having the value Hadoop, it has to be processed by the reducer 0. It is the data, it has to be processed reducer 1. If it is like Hitesh, it has to be processed by the the third reducer. If it is Edureka, it has to be processed by fourth, and then the rest of the things it will go to the default. So any of these things, when there is criteria assignment, it will go to the last reducer, and which will basically get the multiple keys value to process that and give the output. Yeah, it will not be utilized, Satish. If you don't give the output, it will not be utilized. Okay. So those things you can just try it, Satish, while working on your Okay. So now what we will do is let's save this particular program. Okay. And now let's create a jar file here. So let me go here. Control L. Okay, let me make a directory here, mkdir advanced. Okay, so let's go ahead and create a jar file out of it. So how you do that? Export, and then you do a jar file. Next, and you specify where you want to store the jar file. One second, guys. So okay, so here we are going to write my partitioner dot jar. Okay, so this is a jar file of which we are going to create as part of our program, as part of our logic what we have written. So the logic is very simple. We are comparing for each key, and based on that key we are determining which particular partitioner has to be, which particular reducer has to process this particular key. Okay, so it sees the jar file has been created. You do ls-lrt, you have the my partitioner.jar. Let's create an input file also for this one, guys. So let's do gedit and like partitioner underscore input.txt. Okay, and here let's use some of the key words which we use like Hadoop, data, Hitesh, Edureka, and the rest of things. Okay, we have this 4, and then we have something called learning others collection, something like that way. Okay, some data set like this way. Okay, like suppose if I do it like all this laptop 1, 2, 3, and 4. So now if we give this particular input data set to be processed, what will happen is first, it is going to like take all these input data set and will mark like Hadoop 1, Hitesh 1, Edureka 1 is going to mark. After that, since we have written the combiner, it will combine that value also, and whatever the mapper input we have, it will basically get the combined output of that. And once we have that particular thing, what we want to do is that we want to aggregation of these all data has to be controlled by the logic which we have written, that is using the partitioner logic which we have implemented. So based on that, we want to make sure that all of the data goes to one particular reducer. So like Hadoop, it has to go to it's a 0, Hitesh 1, and and like that way, like if laptop 1, 2, 3, since we have not put any particular condition for that, so they all has to go to the the else part, that the fifth reducer, they have to go there. So now let's go back and read this particular run this particular thing. So let's create it directly Hadoop fs hyphen mkdir slash advanced MapReduce. Okay. And let's move this data set. So how you move the data set? Hadoop fs hyphen put this particular data set and move it here. Okay. Now if you want to run this jar file, guys, what is the command we have to use? So now you have the input data set, you want to run it. Of course, we are going to see how the output going to come. But okay. Oh, is that something? Okay, thanks. Sorry, let me just do a quick check. Oh, okay, it's Hadoop. Okay, so instead of telling that, let me. Okay, yeah, thanks, Asurya, for catching that. So instead of this, what I will do is I will change the program itself, and yeah, okay, that's what we have given. Yeah. So now once you change this, Control S and just do export here. So there was a typo, guys, and so like okay, so I just change that one. Thanks, Asurya. Okay, yeah, override it. Okay, so now if you want to run this one, how you do that? What is the command, guys, to run this particular thing? Okay, so the command which you want to run it, it's simple. All you have is the jar file you have and the input data set that is already available. We have moved this data set into this particular location inside the Hadoop. So now if you want to run this, it is Hadoop jar and give this particular jar file name. So this is the jar file name, and give the input data file which you want to process. So it is like advanced MapReduce, and inside that we have the partitioner one, and it's going to consider all the data set, and then output we are going advanced, right, and then you are going to have this advanced MapReduce slash partitioner output. Okay, that's what the data we want to store it. Okay, you hit enter. So how many partitioner we are expecting here, guys? How many output file are we expecting here to come as part of this program? Output as this program. Satish says 3. Okay. How about other people? 1, 5. So how many number of the reducer we said? Those many number of the output file we are expecting, right? Okay. So Ashish, Swagata. Okay, I get it. Okay, Devender. And Hitesh and Meg, help me to understand, like, why do you see it will be either 1, 3 kind of things, right? Why do you think it will be 1 or 3? Okay, Satish says 3 into 3 copy in the distributed computing. Okay, so that is Satish, like in the storage part. Okay, so my question was on the okay. So first, Satish, why first 3, right? Okay, I got the other thought process, like you told that okay, the 3 copies, three data set will be multiplied across 3 different nodes, so you will have those many copies. But how come you the first 3? How you are determining that it will have only the 3 output? Yeah. So guys, when I'm talking the number of the reducer, it's not by default 3. This is something you can configure it. By default, it is set as 1. If you don't specify, there will be one single reducer it will run. Right. After that, the number of the output which you are going to get, it will be determined, based on the number of the reducer you set it. Okay. Yeah. So it is 5, Satish. Yes, you got it now. Yeah. And Hitesh, why you think that it is going to be only one output file? Okay, there will only not for the total aggregated value. If we have 10 reducer, we are going to have the 10 files. Yes, it is. So if we are having 10, then it is going to have the 10 files. Yes. Okay, so it looks like program ran successfully. Okay, now let's go and see that. So let's, where you see this, you go to the name node here and you go back. And you just try to list everything here. So we have this advanced MapReduce, and then we input file we provided. This is the input file which we provided, and then this is the partition output we have. How many files we got it here, guys? You see here 0, 1, 2, 3, 4. How many partitioner file we have got it? 4. Right? So that's what we wanted. We wanted to divide all these data into 4. And what is the logic we have put here for the partitioner? The first part is the reducer, it should process only the value which are for this particular key called Hadoop. Okay, so let's see that what is the output here. You see here, this output file we are getting only Hadoop, that it has come 7 times. What is the second one we have? That is like data, right? So it has just counted the data, rest of the key it has just ignored. Similar way, if you come back here, the third one, it has just counted for how many times the Hitesh, and that's the output we have. The last one is for Edureka, again it has counted. Rest of the things like all these, 1, 2, 3, what we did for this data set, all those went to the default reducer, that is the 5th reducer which we have, and you have like laptop 3 times, 1, 2, all those things are counted by the default reducer. So this way, what you are doing is by writing this particular logic, you are basically controlling how your output data is going to be moved from a mapper to which reducer, and based on that, the aggregation will happen, and your output will be stored in that particular reducer output file. Okay. Okay. So is this clear, guys? Are you guys able to see that the partitioner, by using the partitioner, you are able to basically control how the output file is going to contain which particular. But now you think of this is one example. You think of, like, suppose if you are computing multiple transactional data and you want to segregate that. Okay, the company one, we want to put it one, or for particular geo or for particular cluster, I want to put in all. Now all those things you have to put only the filter in the key, and once you implement that filter as a partitioner, your all the data set will come together as one particular thing. Okay, Minus is clear. How about other people? Is everybody clear with this particular example, guys? Can I get a go? That are you guys good with the partitioner and in the overall logic, how it works, how the file you will be able to control? Okay, Patrick says makes sense. Says yes. Okay, okay, okay. And let me see some questions. Okay, yeah. So okay, let me show it. So now let's go to the job tracker here, guys. And let's see the job which I just now it ran. Okay, so who had this question? Let me. Okay, I'm just Sakta. I'm going to your question. Okay, so Sakta has a question, right? Who had this question? Hold on. Yeah, you only, right? So how the number of the reducer is going to work, right? So in a server, right? When you go, if you come back here, you can see on this particular machine how many number of the map task and the reduced task is capacity is available. So the map task capacity is 2 and the reduced task capacity is 2. So what means in this particular no machine we can run the 2 reducer and the 2 mapper simultaneously. Now what if I want to run 5 reducer? It doesn't mean that all the reducer will not run. It will run, but only thing is since we have the 2 task capacity, only 2 can run at the same time. So rest of the 3 it will be on the queue, and once these 2 slots are complete, then the rest of the 3 will execute, right? So that's the way it's going to work on this particular thing, right? Similarly, map task we have 2. Now suppose our data set is such a way that it need 5 mappers to process that input data set. So in that way, what will happen? 2 will start simultaneously, and the rest of the 3 it will start after that 2 slots becomes available. And that's where the bigger cluster comes in the picture. So if you have more number of the map task capacity, reduced task capacity, you can run more jobs in parallel. Okay. So that's one part to answer your question, Swagata, about how the slots are there, right? Now come back to the current job which has run. Okay, so in this case, you see how many number of the mapper we run, 2, and how many reducer we run. We ran 5 reducer, right? So each of the reducer, it got like one input data set based on the logic which we wrote, and based on that logic, it basically processed all this data, and we got the output, right? So this way, the 5 reducer we were able to run by using the 2 reduce slots which is there in the cluster. Is that answer your question, Swagata, in terms of how things works on this particular machine? Okay. Is there anywhere we can see the number of the task tracker involved? Yeah, you can see this here. So all those things are available in the job tracker. So you see here the task. Yeah, so this task tracker you can see. If there is any output error message, you can see all this all right. So you will be able to see all this standard out, standard error logs, everything you will be able to see here, right? So when the job fails, guys, this will be the the link which will come. So this is the job tracker. You will come and you will see here when the job will fail, it will say that how many job has failed, and kill task, and you will click that. And once you click that, you will basically go this particular thing, task tracker. You will click the task tracker, and then you will go to the the task logs, and you will click the task log and see what are the error message it is having. Okay. Okay. In the output GUI, block size is 64 MB, but the data store is only few KBs. Yeah, so actual data, Vivek, it will be like few KB, but the block size is 64 MB. That's what it is showing that. Okay. Okay. So I think apart from the Hitesh doubt, I'm not sure it's clear. So Hitesh, your doubt with having only one reducer, is it clear now that since we specified the number of reducer 5, that's what we have the total output file as the 5, not as a 1. And okay, so that's all we have. Okay. Yeah. And if this is number of the input split is equal to the number of the map task. If you limit the map task, are we not limiting the parallel job? We don't limit the map task, so that's something you can limit how many number of the reducer you want to run in the cluster, but the number of the mappers, you cannot limit it. That will be basically decided by the framework in terms of how many blocks or how many split you have for your input data. So that's why it is going to determine how many number of map it's going to run. Vivek says, what if the output is more than 64 or 128 MB? So that file will get divided, Vivek, into the different blocks, and each of the blocks will get stored inside the different machines. But whole file you can refer still by the single namespace by using this particular thing. Let me show you here. If I go back here. So part 0, right? So this file internally it can have like, like currently we have 0.01 KB kind of the size. Like suppose if it becomes like 128 MB, so this file internally will have two different blocks which will make this file, but you as a, when you will access with the same file name. Internally it will divide into blocks, and that's where it will be stored. Okay, but that will be something transparent to you. Here the block size you will see like 64 MB, but the actual size it may have like 128 MB or something like that way. You will see it here, but you will be able to access by using the same namespace. Okay. Can we specify number of mappers? No, Devendra, you cannot. Okay, you got it, Vivek? Okay. Okay, cool. It is clear now. Okay, good. Is everybody clear by this concept, guys? Are you able to see the partitioner, everything, how it works, right? I know you have to practice it once, but you understood the whole flow, how you work, and what the partitioner is doing. It's basically segregating your output into the way whatever you want to put the logic. Based on that logic, it's outputting the